Alright, good day everyone. So welcome back to my YouTube channel, and today we will be talking about Wallis formula. So this is Casaligan Vlogs, Calculus 2 and Integral Calculus. So Wallis formula, so we have here from 0 to pi over 2. So take note, sine m, x cos n, x dx, wherein this one in which m and are integers greater than or equal to 0 arises over and over again in elementary application. Fortunately, the integral one can be evaluated by with a formula which is easy to remember in words, though bulky looking in symbols. So there we have to take note that this one, okay, so from 0 to pi over 2. So we can apply this Wallis formula if we could reduce or transform this from 0 to pi over 2. So sine mx cos nx dx, so m is 1, n minus 3, and 2 or 1 to the last part, 2 or 1. Take note 2 or 1, times n minus 1, n minus 3, 2 or 1 times the alpha, if the alpha is pi over, in which alpha is equal to pi over 2, m and n are even. If the alpha is equal to 1, if otherwise, meaning this otherwise, if either 1 or both are odd. So either this is 5 and 6, or one of the m or n is an odd. So if the first factor of any of the products to be performed in applying Wallis formula for m, n is greater than or equal to 0 is less than 1, replace the product by unity. So take note, so until it's n to 2 or 1, until it's n to 2 or 1. So take note that n is 0 reduces to this formula. So this one, if n is 0, from 0 to pi over 2, so where alpha if is even and alpha is odd. So if n is 0, it simplifies also this form, but alpha is even and alpha 1 is if it is an odd. Okay, let's try first number 1 example. So this is the example that we had uh, during the definite integral, the last two examples. So this one, so the first we have to determine m and n. M is equal to 4 and n is equal to 2. So therefore, they are both even. So take note that if they're both even, we have to multiply it by pi over 2. Okay, so if both are even, we have to multiply it by pi over 2. Okay, so let's apply the formula. So integral of sine 4x cos squared x dx from 0 to pi over 2. So apply it only when it is pi over 2 dx is equal to the first one. We have to apply what is our m. Our m is equal to 4. Therefore, this is 4 minus 1 times 4 minus 3. So it should be from 0 or 2 or 1. Therefore, this is 1 already. So we have to multiply times our n is equal to 2 minus 1. Therefore, 2 or 1 over our m plus n. So what is our m is 4 plus 2. Then next is 4 plus 2 minus 2, or 2 or 1. So the rest is 2 or 1. Still, we have the next part is we have 2 minus 4 plus 2 minus 4. So times, since this is even, both are even, so multiply it by pi over 2. Again, 4 plus 2 minus 2, it should be 2 or 1. Here, 2 or 1, the remaining should be 2 or 1, and here is 2 or 1. So 4 plus 2 minus 4 is 2, so therefore that's enough. And this 2 minus 1, that's enough. Okay, so next part, we have to subtract. So 4 minus 1, 3, times 4 minus 3, that is equal to 1. And this is equal to 1 over, this is 6, this is 4, this is 4 plus 2 minus 2 is 4, and this is 4 plus 2 minus 4, that is equal to, alright, 4, that is equal to 2. Then multiply it by pi over 2. So this is, okay, we have to multiply, okay, we have 6 times 4 times 2, that's 48, 3 pi over 48 times 2 is 96 divide 3, that is 32. So therefore 3 pi over 96 is pi over 32. So this is the answer, example number 1. So let's proceed with example number 2. For example number 2, since it reduces to the form, okay, it reduces to the form sine raised to 5. So this one is an odd. So therefore, if this is an odd, we are multiply it by 1. So first, we have to determine our m. M is equal to 5. So integral 0 to pi over 2 and sine 5x dx is equal to, the first is we have to m1 minus 1. So therefore, 5 minus 1. Next is 5 minus 3. The remaining should be 2 or 1 over the remainder, or the denominator is m. So 5 times 5 minus 2. So 5 minus 2, then it should be 2 or 1. 5 minus 4. Okay. 5 minus 4 multiplied by 1. So 2 and 4. So we have here 4 times 2 over 5 times 3 times 1 times multiplied by 1. So we are going to have 8 over 15. So integral of 0 to pi over 2 sine 5x dx is equal to 8 over 15. Next in line here, example number 3, 0 to pi over 6 cos 8 3x dx. Since that is pi over 6, and we see that the theta is equal to 3x, so let us first let theta is equal to 3x. And d theta is equal to 3 dx. So therefore, our d theta over 3 is equal to dx, or the neutralizing factor is equal to 1 over 3, 1/3. So this, we have to transform, since we have to use the Wallis formula from 0 to pi over 2. Since this is 0 to pi over 6, so since the angle is 3, so multiply pi times 6 times 3, that is pi over 2. So now we can transform now. This is 0 to pi over 2, and the NF is 1/3. We have to put it 1/3. So 0 to pi over 2, that is, we can transform this as 0 pi over 2 cos 8 theta d theta. So now we are going to have cos 8 d theta that is in a form of, this is even. So if even, multiply it by pi over 2. So first step is you are going to have 1/3, copy this one. So multiply it by, first, what is our m? Rn rather. Rn is equal to 8. So therefore 8 minus 1. The next in line is 8 minus 3. The next in line is 8 minus, okay, 7. Next is 5. 8 minus, if this is 3, that is equal to 5. Then times 8 minus, that is equal to 7. Minus 7. So it's 1 or 2. So therefore this is 1 already. Then the denominator is 8 times n minus 2. That's 8 minus 2 times 8 minus 4 times 8 minus 6. So therefore, we are going to have to take note 2 or 1. This is already 2. So times pi over 2, because the n is equal to 8. The given is even. Okay, that's even. So we have going to simplify. So 1/3. So this is 7 times 5 times 3 times 1 over 8 times 6 times 4 times 2 times pi over 2. If we're going to multiply this one, so this is 7 times 5 times 3, so 1/3. 7 times 5, 7 times 5 times 3 is 105 pi over 8 times 4, 8 times 4, 8 times 6 times 4 times 2 times 2 times 3 is 2304. We already multiplied it by 1/3, so therefore 105 over 2304. Okay, 2304 divided by, okay, let's a bit. So we have here 7 times 5 times 3, that is 105. 304 divided. Okay. Then next we have more, we're going to multiply it by this one. 8 times 6 times 4 times 2 times 3. Okay. Then 105 divided by, okay, this, the answer is 35 pi over 768. So this is the answer for this one. So that's example from 0 to pi over 6 that we converted or transformed. That is the angle. The upper bound is pi over 2 now. So let's proceed with the next example, which is here from 0 to pi over 2 sine raised to 8 cos 4 dx. So this one is both, our m here is 8, our n is 4. If m plus n is equal to 12, So both are even, so therefore the R of alpha is equal to pi over 2. Okay, next we are going to have simplify 0 to pi over 2 sine 8x cos 4x dx is equal to 8 minus 1, then 8 minus 3, 8 minus 5, and this is 8 minus 7, and multiply it by n, which is 4 minus 1, 4 minus 3, over 8 plus 4, then 12 minus 2, then 12 minus 4, then 12 minus 6, then 12 minus 8, and 12 minus 10. So therefore, we are 1 or 2, the remaining, times pi over 2. We are going to have 7 times 5 times 3 times 1, then times 3 times 1 over, this is 12 times 10 times 8 times 6 times 4 times 2, then multiply it by pi over 2. So 7 times 5 times 3 times 3 over 2 times 10 times 8 times 6 times 4 times 2 times pi over 2. The answer is 7 pi over 2048. Okay, let's recap. 7 times 5 times 3 times 3 over, okay, again 7 times 5 times 3 times 3, that is 315. Okay, then 12 times 10 times 8 times 6 times 4 times 2, that is 4 times 2, 92, 6 ones, 160, 92, 160 pi. So therefore we have, okay, 315 over 92, 160. So therefore they have 7 pi over 2048. So let's have try this. Use Wallis formula to find or to solve this problem or equation. Thank you so much for listening, and I hope you learned something about Wallis formula.